just have to record the session. It's very important, right, for all of you to revisit the lecture some point of time. So the crux of the story is till now, the today's lecture is fundamentally about introduction to the coding and introducing you to very fundamental concepts like computational thinking, algorithms, and computer programming. I just told you one very important fact कि जो भारत सरकार है, they have recently came up with the national education policy, right, where they want this computational thinking to be imbibed at a grassroots level in our education system, right? And friends, we are already using this in our day-to-day life. So through examples and discussion, I just like to showcase you, जैसे हनुमान जी को याद दिलाते हैं, right, their powers. In a similar way, I'll just make you remember again that you're already using these things in your day-to-day life, right? Just as an example. So I've just put up a case study where what is happening, there's an urban area in Delhi, Gurgaon, right, where you can see there is a traffic congestion, right? It's somewhere in Dwarka and Gurgaon interface where there is merging traffic and the volume of the traffic is way more than what the traffic can be handled, right, in the roads. Because again, poor public transport, blah, blah, blah. Hundreds of reasons leading to pollution, frustration, leading to a poor socio-economic life, right? That's a case study, friends. And that's the challenge or the problem statement. Now, the city officials, the decision makers, for example, the transportation department, they devise certain questions, right? In this case study. What is this? What are the questions? They say, what is the main cause of traffic congestion? Is there, can the traffic flow be optimized? Is it possible? ऐसा है कि is there a way, for example, there could be some part of the road which is broken, for example, right? So you may fix that and that might lead to, reducing the delays, for example. Similarly, what measures one can kind of adopt so that people reduce the reliance on private vehicles? अब इस image में आप देखो, there are most of what do you see in the image, friends? Chat box में quickly क्या दिखाई दे रहा है mainly image में? Please tell me in the chat box, what do you see in the image? The visual demonstration cars, excellent. So these cars are basically private vehicles. And also what you see is there is a back end में एक बस भी दिख रहा है आपको side में, right? So that could be a public transport. You can just imagine if multiple people kind of get into that bus, we may reduce the volume of traffic in this road, right? So the traffic department also postulates one more question, कि क्या there could be some alternative modes of transportation, and if yes, how people would be encouraged that they follow कि आप metro में travel करें, आप you travel in the public transport. So these are the questions that are posed by the traffic department, and basically as a solution they again got some some scientific team and which had I mean knowledge of transportation engineering. That's a domain in civil engineering, and they kind of collaborated with the computer science department, say in their organization, and they came up with this solution called as DTSOS. That's Dynamic Traffic Signal Optimization System. Now, what is that, right? Now, city officials implemented DTSOS to improve the traffic flow and reduce the delays. Now, this solution, ठीक है, अब ये implement तो कर दिया उन्होंने, as a case study, as somebody who wants to understand the know-how of computation, coding, and all that, one needs to understand कि साहब ऐसा क्या जादू की छड़ी थी उनके पास that they could implement such a solution. So what did they utilize, friends? They utilized computational thinking, they utilized algorithms, and they utilized coding to ultimately dynamically adjust the traffic signal. So there are three new words which are being introduced in this case study. Number one is computational thinking, number two is algorithms, and number three is coding, right? One by one. What is computational thinking? There's a message. Okay, great. I hope everybody is following it. है ना। अभी तक कुछ ऐसा देयर इज नो रॉकेट साइंस टिल नाउ, बट ये तीन जो दो कॉन्सेप्ट्स है मेनली जो स्लाइड में आपको इंट्रोड्यूस करूंगा, जस्ट ट्राई टू काइंड ऑफ गेट कनेक्टेड टू इट. So computational thinking is nothing, friends. It is basically two steps in a broader perspective. पहला क्या? When you have to do computational thinking, you have to identify the problem, right? So computational thinking was employed, and basically they analyze the traffic data कि कितने vehicles आ रहे हैं, what is the volume, what is the congestion, right? Is there any bottleneck? Bottleneck means कोई ऐसा इंटरसेक्शन है जहां पे ट्रैफिक की वॉल्यूम सडनली बढ़ जा रही है, राइट? दैट्स बेसिकली आइडेंटिफाइंग द problem, right? Secondly, if yes, they identified the problem, the second step in computational thinking is breaking down the problem, right? Basically, in computational thinking techniques, what one do is you define small chunks of components, right? For example, what one can do is you can just look at the signal timing, right, at one of the specific intersections, right, across. अब आपके आप समझो, there's a long road of traffic, right? Now you don't need to look at the entire traffic volume in one go. You break down at a particular location and just focus at one point. For example, you can look at the red light area, जहाँ पे red light की जो timing है, and you may just amplify or you may just identify कि ऐसा हो सकता है कि in a particular direction, for example, दिल्ली से there'll be more traffic coming in the evening and there'll be less people who will be going back from Gurgaon to Delhi, right? So I can dynamically adjust the red light timing and somehow reduce the load on the traffic junction. Is this clear to everyone? ये concept समझ में आया? Breaking down the problem, what I just given as an example, great, right? As a very simplified way कि जो बड़ा सा प्रॉब्लम है उसको पकड़ के छोटे प्रॉब्लम में तोड़ डालो, right? That's the first step of computer. I mean, the second step after identifying the problem, right? Now, next, what did the transportation team did along with the computer scientists was they designed an algorithm, right? Now, what is this algorithm? Now, algorithms were again developed. What they did, they installed a camera, right? And they analyzed the real-time traffic data. For example, is समय they just tried to look at the data key at what hours the at what particular hours the traffic is basically increasing, right? Fundamentally, yeah, 6 p.m. Absolutely, Shubhani, great, because that's the time everybody goes back from their workplace, right? The business places, or not just working officials, but everyone, right? So सबसे पहले उन्होंने डेटा को लिया, right? You can just imagine they just put up a camera on one of those intersections and they just looked at the traffic volume, ठीक है? और उस ट्रैफिक वॉल्यूम में उन्होंने क्या किया? पैटर्न फाइंडिंग किया कि क्या कोई पैटर्न है साहब, क्या वो किसी समय पीक कर रहा है, राइट? फॉर एग्जांपल, आई जस्ट ट्राई टू प्लॉट इट एज अ सिंपल ग्राफ, right? As in time is on the x-axis. So is it like the traffic is peaking like this and then coming down? Is it like a particular window between 6 to 8 p.m., right? So first was analyzing the data and then based on that trying to find pattern in your data, right? That is also the part of algorithm, and then ultimately रियल टाइम ट्रैफिक के बेसिस पे दे प्रिडिक्ट द ट्रैफिक पैटर्न. अब बेसिकली एक बार जब आपके पास ट्रैफिक पैटर्न का डेटा आ गया through different equations, and we'll learn all of these things in the course, friend, right? We'll be able to predict temperature. I'll give you an assignment, right? A capstone if you are interested, but for sure an assignment जहाँ आपको winter, इस बार हमारा कोर्स हीट वेव के टाइम पे गुजरेगा. So you will be given data and you will have to predict will there be heat wave in your city, right? So you'll have to download few years of data, analyze the patterns, and then develop an algorithm and predict will there will be heat wave, right? Or some other signature you might be interested in, right? And this will be an example. So that's the point of designing the algorithm. These algorithms determine the optimal timing for traffic signals. अब एक बार उसके पास डेटा आ गया, उसने प्रेडिक्ट कर लिया पैटर्न को, उसने ऑप्टिमल टाइम बता दिया. So whenever you design an algorithm, there is also something called as algorithm optimization, friends, right? जिसके लिए we do a lot of testing and validation, right? So you develop a system, then you implement it, you roll it out. फिर आप उसको day to day basis पे देखोगे. Because see, if I develop a system, एक बार में you cannot develop a perfect algorithm, right? I hope you are understanding what I'm trying to say. If you're trying to develop an algorithm, you cannot develop a perfect algorithm in one go. You have to develop, then put it to testing, right? Then you validate, then come back again with more data, improve, improvise, re-implement, right? So any any operational system, right? For example, I'll just give a practical example. In Bihar, in my organization, we implemented a fog forecasting system for this year. It was the first of its kind in India, right? So what happened? We looked at, uh, are we able to capture the fog very accurately? We observed कि जब भी dense fog होता है ना, we are able to very well capture it in advance, 3 days around, 3 days lead time. But जब भी shallow fog होता है या moderate intensity का, our system is missing it, right? So now what we do, we go back again, try to find the patterns, look into the data, improve our model, come back next season with the improved version of the model, right? So that's the designing of algorithm and optimization of algorithm, right? The second thing, computational thinking, algorithm. I hope everybody understands it, friends. It's must to be accurate, reliable at the same time. Absolutely. And एक बार में ये accuracy or reliability we won't be able to achieve, Shubhangi, right? It is something which will happen over time, right? So we need to always test, validate, and come back again by improving the reliability. And for sure, any system which you are developing, any model you are developing, there is always scope for improvement. ऐसा कहते हैं ना, for example, if you develop a model और अ पैटर्न इन वन गो और वो पूरा एक्यूरेट हो गया ना, मतलब कुछ चीटिंग हो रही है. देयर कैन नॉट बी अ परफेक्ट एल्गोरिथम और अ परफेक्ट मॉडल. इफ समबडी टेल्स कि कल टेम्परेचर 25 होगा और एग्जैक्टली 25 हो गया, so somehow you may think no, this guy is bluffing, right? It's not sure. उसने 25 बोला, 24.9 हुआ, 25.1. That means yes, there is scope for improvement. Regularly should be maintained for it. Yeah, absolutely. So can we see in algorithm predict trends and patterns? Absolutely. We identify patterns, right, in the data. We look at the data and then we basically do trend analysis. You can say that, right? We try to predict something, whatever is under the subject of interest. Is that clear, Urja? This is what it means. Absolutely. You have hit the nail on the head. This is what algorithm is all about. All right. So the second thing is clear. The third and the next important concept, that's basically coding. Okay. Now coding the solution, friends. So what happens? The role of computer programmers come after, technically as computer programmers in this course, you'll be taking care of all these things. आप computational thinking भी करेंगे, you will be designing your algorithm in your head, and then you'll be translating that in the form of a code, right, through a programming language. For example, Python in this case, right? So friends, the DTSOS system in this course, basically the software system was based on the real-time traffic data from different sensors, surveillance cameras. The data, the data was analyzed, and an algorithm was developed, and ultimately traffic signal adjustment का एक program develop किया गया, right? So automatically, based on the hour of the day, the timing of the red light of that intensity, right, green and red, will change so that you have a optimized setup and you don't face, the traffic congestions, right? I hope you understand it. This was a case study to introduce you what coding, algorithm, and computational thinking is all about, right? So we develop it in our mind, right? Through computational thinking, breaking down the problem, and then ultimately we implement that physically, right, in the software world, where, for example, in this case, we're using Python to implement these things. Okay, I hope that's clear to everyone. All right. So if that is clear, let's together look at a small video for a few minutes. that again introduces you to what is computational thinking. क्यों important है computational thinking? Let's just together look at this video. Please tell me the sound is visible, audible to everyone. Okay, great. All right. Did everybody listen to the video? I hope there was no noise. Okay, great. So let's change the slide. So ultimately, friends, what was this video all about is the computational thinking. And primarily, I just like to say our computers are becoming smarter in tomorrow's changing world. We have to know, not only know what is, we also have to know what is to be, right? And all that is only possible by two things, not only by critical thinking, of course, we do our education, teaching, where we kind of learn a lot of critical thinking through theoretical studies, etc. But in changing world of tomorrow, there will be large amount of data readily available for everything. Our data, for example, we are using, different, for example, social media. Everybody is taking our data as well, right? I hope you would have seen that you were planning with your friends or somebody to buy uh, buy some product, and next day you see that Google is showcasing that, right, as a possible product for you to buy. So everyone is gathering the data from us, and so it's very important in today's world that we are computationally aware, right? So that's the third and the most important vertical of our course, to develop computational thinking, right? So all in all, if I have to just tell you, जो मैंने वीडियो में दिखाया आपको, what is computational thinking? Computational thinking is a problem-solving approach that involves breaking down a complex problem into small, more manageable parts, identifying patterns, trends, and designing algorithms to solve them effectively, right? So there is something called as algorithms, which I'll explain to you in a minute. But for now, you can just think the computational thinking is composed of these four key components, right? Decomposition, यानी कि बड़े प्रॉब्लम को छोटे प्रॉब्लम में तोड़ लेना, right? और डेटा के बेसिस पे, right, on that small area where you are focused, you try to look at the pattern recognition, right? Also, what you basically do abstraction, as in, what does abstraction means? For example, you might be focused on the traffic problem. Simultaneously, there could be, for example, वहाँ पे there could be a waste treatment plant, which is also a problem, but you don't need to bring that into your current problem, right? That's a separate case. So this abstraction is equally important in the computational thinking. And finally, you have to develop the solution. That is what algorithm development or algorithmic thinking is all about. Okay, so that's the first of the important concepts. Similarly, what is algorithm? If I have to just explain to you. Okay, great. I hope it's clear to everyone. So what is an algorithm? If I just open up my dictionary and put this word algorithm, right? Often, algorithm word को ऐसा प्रोजेक्ट किया जाता है कि ये बहुत कॉम्प्लिकेटेड साइंस है, right? That there is an algorithm to do this, right? You had already heard somebody saying that. But algorithm, my friends, is just a set of steps to accomplish a task, right? Algorithm is nothing, just a set of steps to accomplish a task. और हम अपने day-to-day life में we are surrounded by algorithms around us. For example, बचपन में, when we were kids, would have learned to riding a bicycle, right? So there was an algorithm, right? You had to put yourself on the cycle, put both your feet on the ground. जब पहली बार साइकिल चला रहे थे, just try to remember that moment in your head for a brief second, right? And just taking you back. Then I'll call you back as well. So उस समय क्या कर रहे थे? Just trying to put your legs on the ground. फिर we had our elders who were supporting from behind as well. कि तुम you ride, will hold from behind. And there was a day जब हम चलाते चलाते there was no one behind us and we learned riding a cycle, right? I hope you would have witnessed that feeling. But ultimately in your brain, there was an algorithm which was working. कि इसके बाद ये, I have to hold the things. There is a brake to stop. If I paddle faster, the cycle will move faster. If I paddle slower, etc. So yeah, exactly. From two extra supporting wheels to main axle, and that's the point, right? From that to becoming independent, bicycle riders, right? So that was also an algorithm. Tomorrow, or we often go to a grocery store to buy something. जहाँ पे हम पूछते हैं भैया, where is this product जो मुझे चाहिए? He says you go right to the aisle, take a left turn, end में वहाँ पे आपका product होगा. What is the guy saying? He's selling me an algorithm. I have a problem that I need to find a product, and he has arranged, the things in a structure in his mind, right? There is a structure in the mind of the grocery owner, and he gives me a step-by-step guidance. Basically, he gives me an algorithm to go and find my product. Similarly, there's somebody catching a train. Catching a train, friends, is also an algorithm. Remember the first time you would have boarded a train or metro, right? If you remember, gate खुलने के बाद ही हम अंदर जा सकते हैं, right? या जब हमारा number आएगा, if there is a queue, we can only go then, right? We'll have to, for example, climb couple of stairs to come to the level of the coach, etc. Then take a route somewhere to our seat. So that was also an algorithm. So that's what I said in the starting of the course. I'll be just trying to introduce you certain things, right? Which you're already doing it, right? Knowing or unknowingly. जब भी कोई कंप्यूटर प्रोग्रामिंग की क्लास होती है ना, so ये एग्जांपल हर जगह आता है. So I just put that as well, right? People when people have to explain an algorithm, they say they give this example. So without making any of our forefathers any injustice to this famous algorithm, I just put this slide as well, right? For example, if somebody has to make a sandwich, he has to take a slice of bread, put butter, put tomato, whatever as a filling, cut the sandwich, put it together, right? You can have another slice above it, and then eat and enjoy, right? That's another algorithm of the making a sandwich is also an algorithm. Of course, these are very simple algorithms, but in computer science or in the computer world, friends, algorithm is fundamentally defined by three things, right? There will be three steps. There will be some input data, right? जब भी algorithm develop करना होगा, for example, अगर हम अपने case study में लौटे, right, where we are trying to find an optimal solution to the traffic lights, right, because of the congestion. So there was some input data, matlab, there was some data through which one can look into the traffic volume, right? So in computer science, whenever you will develop an algorithm, there'll be some input data, right? On that input data, you will do some calculations, right? For example, you might try to find out some statistics, right? You might find a mean or a median kind of a thing to get an idea, right? And then after doing some calculations, right, finding something out, you will get an output, right? This output would be a solution. For example, in our case study, what is the optimal time window of the red light when there is the peak intensity of traffic? That's the output, that's the solution, right? Looking at the data, the computer scientist who was in that transportation department, he said कि साहब चारों दिशाओं से ये अलग-अलग volume of traffic आती है, and if I'm seeing congestion on this particular way, so I need to increase the traffic light so that more vehicles can pass in this direction. So I have to accordingly tune the red light timings in such a way कि जो दूसरे साइड की ट्रैफिक है that will have a shorter stay time, while this will have a longer kind of a way to transfer the transport in one direction. So that's the way you basically come up with a solution through algorithm, right? So computational thinking and algorithm. Of course, this is I just like to not just showcase simple examples, but also, for example, Abhi, we are speaking. I can switch on my video. I'm doing an audio basically, which is going to your ears. So we are on an online meeting platform, right? For example, Google Meet or Zoom. Yeah, Zoom is also using an algorithm. That's basically an audio visual compression so that all this data is reaching to you in real time, friends, right? So this is also an algorithm, an audio visual compression algorithm, right? There are numerous algorithms, right? From sorting data to filtering data to as complex as this kind of a technology where you have an audio visual compression algorithm, where, for example, this image you can see Barack Obama is sitting on a real time on a video conference, right? Just like us, right? In this Zoom meeting. Similarly, friends, this is the International Space Station, right? It revolves around the Earth, right? Or it's stationed around the Earth to kind of monitor the different, activities in the space. But what happens is this also needs power, the International Space Station or the satellites as well, because and for that they have solar panels, right? So we know that in 24 hours there is one hemisphere which is facing the sun, the other is not. right? So similarly, these satellites or the international space stations, they have a optimization and scheduling algorithm जहाँ पे वो sun synchronicity के basis पे they align the solar panel. This is also an algorithm, right? So right from somebody who's riding a cycle to some space station, which is thousands of kilometers above, not thousand few kilometers above our in the atmosphere. It's we are all surrounded by algorithms. Ultimately, somebody in NASA wrote this code few years back. Then only this ISS, right? Not ISS, sorry, ISS kind of is able to perform optimally, right? That's the optimization scheduling algorithm. Similarly, this is, I mean, it's very close to my heart because it's of my field. Based on the laws of atmospheric physics and chemistry, right? Ultimately, hum jante hain, as you know, if you have studied atmospheric sciences, I'm sure you all would have in the environmental sciences, training at the A.S.S. Science Academy. So you would have looked at the winds, right? The geostrophic winds, they're all equations, right? Now, all those equations in the form of algorithms are fed to a computer model. So this is basically a chemical transport model from NASA where you can see how the carbon dioxide transport is happening. This for the year 2006. I've just taken it from Google, but friends, this is also an algorithm. There are certain steps one by one, which is basically this is algorithm combined with computer programming and data visualization to give you an interface. But at the back end, this is also an algorithm. I hope everyone is able to appreciate and understand. हो सकता है you are knowing this already from two extremos here. Any doubts, anybody? I hope everybody is understanding कि क्या होता है algorithm, what is computational thinking, and all this is around. Okay, great. So finally, what is an algorithm? An algorithm is a step-by-step procedure or a set of instructions designed to solve a specific problem, right? Or perform a particular task, right? It is a finite sequence of well-defined, unambiguous instructions that, when followed, lead to a desired outcome or a solution. Algorithms can be expressed in various forms. It can be like in natural language, flowcharts, pseudocodes, or programming languages. This is what is for our interest in this course. We'll be doing in the case of programming languages. So, Kalko, when we look into loops, we'll look into conditionals. There'll be an algorithm which I'll explain it to you. कि computer में क्या हो रहा है, how is the program working, right? In the days to come. And you have to always understand if there is an algorithm behind it, right? And to break it down, just like computational thinking, algorithm के चार basic components होंगे, right? There'll be a starting point, right? Some input data, for example. Then there'll be a sequence of actions which you will perform. There'll be some calculations on that input data you will perform. The most important thing in an algorithm, there should be a stopping criteria. एक algorithm में अगर calculation start होगी, right? So it has to end at some point. Else it will keep on and on going on as an unending loop, right? So that is what is the next step, the clear stopping criteria. And ultimately, there has to be a solution to the problem, right? So for example, in our traffic case, the traffic congestion case, we had a solution, right? We got an optimal timing in our case. So that's the kind of a holistic perspective of what an algorithm is all about. So everybody, is it clear? Algorithm and computational thinking kya hota hai? This will be the grassroots of our course. Whatever we will do will be aligned in this direction, right? And as I told you, always we should be aware in our day-to-day life, whenever we are doing such an operation, there is some algorithm which is running behind it, right? For example, हमने GIS के केस से भी देखा था, right? When we talk about there is a spatial algorithm, we'll be looking into some of those cases in our GIS lectures, right? When we'll develop heat maps or other things. Like looking at a nearby petrol pump, right? In Google, in case of Google Maps, there is a spatial algorithm which is running in the backend, right? It is taking some data, spatial data, doing some operations, and based on the nearest neighbor approach, it is giving you the location of the nearest petrol pump, right? So that's an algorithm which is being implemented there as well. All right. Now, coming to the next part or the third part, right? To kind of, understanding computational thinking and algorithm development, but you need something to basically implement that and, create as a solution, right? And to do that, computers are the things which make it possible for us, right? And computers, basically, they are like our friends, right? This I have taken some of the slides from our first lecture, which will be restarting again, right? From once we are in the Python world, first we'll be doing a lot of GIS and statistics. Then we'll come to the coding part, right? In this next few weeks. But technically, I've just borrowed some of my future slides. Friends, जब भी आपको computers के बारे में, when you have to understand, whenever you have a computer in front of you or whenever you are working, right, you have to always understand the computers have been built with only one purpose, right? That to do things for human beings, right? They have been just given a task to do the things for human beings, right? But there is one small catch, right? If you want computer to help you, you have to speak the language of the computer, as in you have to communicate to the computer in that particular language, right? So to make somebody, for example, if I don't want to use the word like servant, but if say I have a friend, right? If I am caught up in some problem, right? And I need some help from him. So I need to communicate properly to my friend, ki, boss, I'm stuck in such and such problem. Please come here and help me, right? So to do that, I need to do a communication, right? It's a communication. Then only my friend can understand and come and help me, right? So that's how the computers basically has been built. And the only catch is we need to learn to speak their language. So in this course, through the algorithms and computational thinking, we'll learn one of the languages which the computer can understand, and that language is Python. Okay, we'll be an expert in that from a beginner to an advanced level, right? We'll have a thorough journey. We'll be able to do a lot of cool stuff by the end of this course. Similarly, friends, if I were to just talk about in terms of computer programs in particular, computers से हम communicate करते हैं through computer programs, right? Basically, as I told you, you have to speak their language. और सिर्फ language बोलने के बाद there should be a set of instructions, right? There should be, I just don't want to speak just one line. I would like to give a certain set of instructions, right? That is done through computer programs, right? And whenever you write a computer program, always remember that her statement के बाद, the moment you write up one line of a code, computer will execute that and straight away jump up and say, what's next? Then you need to give another set of instruction, right? So what you see on the left-hand side is just I'm trying to give you a perspective. This is from my mobile phone. I'm just trying to showcase there are different applications, right? Now these applications are nothing. These are small computer programs which have been built up to be helpful, right? And I'm just trying to give you, abhi tak hum screen pe, if you are enrolling to this course, you're taking this course, अभी तक आप कंप्यूटर स्क्रीन को सामने से देखते थे, right? But आने वाले दिनों में you will be basically looking at from the other point of view and an understanding what is there inside each of these programs, right? Ultimately, what you see over here, there are different applications, Facebook, YouTube, etc., etc. These are all basically applications which are nothing simple computer programs, and you can just imagine this is not Facebook, it is just a pop-up saying what's next. As in, you will open it, you keep on feeding instructions to it as a user, and keep asking questions, and computer always has a question, what's next, right? So the key summary of this slide, and remember this for this entire course, is computers want to be helpful, computers are our friend, but there's only one catch. We need to instruct the computer for what's next, and for that we need to learn to speak to a computer. All right, okay. So I'll just try to, before kind of, augmenting or putting you aligned towards a computer program, let's first try to see what a human program is, right? So what you see over here is there's a famous Bollywood song, right? Few years back, not famous, quite old now. I just like you to read this as line by line, right? That you can just imagine this is a human program. It's saying left leg aage aage, right leg piche piche, right? So can you just read through the lines and try to understand what is happening? Is there any, is there any error in this program? Or is there any error which you can find in this human program? Can you just look into it and try to locate कि क्या कोई गलती है यहाँ पे या सब सही है? Anybody? Let's start होना चाहिए, okay? Okay. So if there's only one mistake, so let me just play the video and we can just look into what exactly it is. Please give me a confirmation in the chat box ki sound visible hai, because this is a human program which I'm just trying to give as a problem statement to all of you. Sound visible, audible, audible, audible.
Left leg, आगे right leg, पीछे पीछे आजा यारा, let's start away. सर को घुमा ले round, पैर जरा up down, इतनी सी ये बात वे. वो बनता ही क्या है जो नाचे ना गाए, हाथों में तू हाथ थाम ले. ओए डांस पे.
Yeah. So basically, in this human program, there were certain errors which were made. Right? Exactly. बंदा की क्या राइट राउंड को राउंड डबल डी लिखा हुआ है, चांस पे डांस को फ्लिप कर दिया गया डांस पे चांस पे, राइट? नाउ बट इफ यू जस्ट इमेजिन फ्रेंड्स, some of you did point out the mistakes, but in general, as a human mind, as a human program, we have been trained in such a way that we often overlook the syntax and keep moving ahead, right? For example, this is also an algorithm as a point of view, right? You understand what an algorithm is, step-by-step instructions. So यहाँ पे, for example, if there is this human program, it will keep scanning line, one line, two line, three line, fourth line, and then go to the next line as well. But in case of computer, the moment it oops, the color is very bad. We just change it. The moment computer, in case of the computer world, if it understands ROUND, not ROUNDD, so your program will stop at this line, right? So the what's next will stop at this point, right? It won't move to the next step, right? Why is that the case? Because computers are more specific, right? Computers are not like, we human beings, somehow we naturally perceive the inconsistent world. हमें चलता है ये थोड़ा बहुत typo हो जाए तो we are not able to conceive in such details, right? Reading across the words. We are not good. Our human brain is made to do much bigger things, right? For example, designing an algorithm or designing that space shuttle ka algorithm for augmenting the solar panel ka direction with the solar radiation. We are good at developing those large scale things, but our brain is somewhat, I would say, perceiving this. We naturally perceive the inconsistent world, whereas the computer in this case is very precise, friends. The moment it encounters something like this, it throws up an error, something which is called as a syntax error. Our minds are trained in such a way that we're trying to overlook and it exactly. Urja, that's the point I'm just trying to make through the naturally perceiving the inconsistent world. Absolutely. So that is where is the difference between a computer mind and a human program, right? So अगेन मैंने अभी आपको कंप्यूटर माइंड के बारे में ज्यादा बताया नहीं है, आई जस्ट गिवन यू की सिंटैक्स एरर हो जाएगा, राइट? अभी हम इन चीजों को बहुत डिटेल में देखेंगे आने वाले दिनों में, बट just give me a, so there's a message. Yes, we can say when we even type our keyboard autocorrect itself. Excellent. That's the point. So now there is a program for computer. ठीक है, अब क्या है, आई एम जस्ट गिविंग यू एन असाइनमेंट फ्रेंड्स, मुझे ये बताओ, मैं आई हैव जस्ट रिटन अ टेक्स्ट इन फ्रंट ऑफ यू, यू हैव टू टेल मी विच इज द मोस्ट कॉमन वर्ड इन दिस टेक्स्ट. Anybody? Car, tent, clown, car. Okay. Was anybody getting irritated because of these dancing words? Sorry, friends, there was a power disruption. So basically, am I audible again? In the chat box, please. Am I audible? Okay, great. So, friends, see what I was doing was I was deliberately, causing these dancing of the words. And our human mind is not basically built in such a way to focus on these dancing words and try to come up with the most common word. And that is where computers are an expert in doing these repetitive tasks. One can just write a simple computer program, which is shown in this slide, where nothing happens. You just input the text, right? Exactly, it's psychologically pertaining. What you just see is you run the code and you find out that the word has come 7 times in the code, right? That is the most common kind of a word being used. So we'll be able to write these codes, by the end of, I'd say, the first session of our Python, when we will, kind of wrap up the fundamentals of Python and move to advanced Python, one will be able to write such a code. Okay, so nothing to worry. These are just syntax, and we'll be able to understand each of these things of detail, right? And do very complicated tasks, which will be very difficult for, say, a human mind to count. Just imagine in this case, यहाँ पे तो is a very small text. If imagine there are millions of words, right? Then it will be very difficult, very tedious process counting. But computers are built to do such stuff like that. They can over and over do repetitive stuff and get the solution. And for that, we need to make them work. And the methodology to make them work is through Python. Okay. So with that, that's the introduction to the third vertical. And in this course, right, we'll be understanding or dealing with a lot of computational thinking, algorithm design, and primarily we'll be working with Python programming to solve the real world problems, right? And also there'll be a lot of interface things. Your last assignment will be at an interface of GIS, Python, and statistics, right? As I told you, there are no capstone projects predefined for anybody. If anybody wants to do it, you can request. We will design a specific project for you by the end of the course to, if you want to do it. But for sure, there'll be compulsory assignments And one of such assignments, based on what we looked in the 3 lectures, will be uploaded in the Google Cloud. Okay, just go and have a look. One of them might already be there. Couple of more assignments will also come up there. Just try to practice and look in what all we have read till now. When we meet next, we start our journey in a dedicated manner to GIS. Okay, friends. So I wish you all a very happy week ahead. Please practice the questions which will be shared. And our model will be somewhat different in this course. Every week we'll learn some Python and some GIS, right? Some mix and match kind of stuff will be there, right? Not 2 years of continuous GIS. That becomes a bit of boring. Okay. So today was the last demo class. Please do discuss with Gaurav sir on the modalities. And it was very nice speaking with all of you and sharing the insights. Hope we continue our journey ahead. Thank you.